Hey guys, in this video we're going to be covering target 1D.2, which is being able to solve exponential equations by using the powers of exponents to get a common base. All these problems can be solved following these couple steps, right? Steps 1 through 4 right there. Our first thing is to try to get the base with the exponent alone on one side. So looking at our first example, I have 2 raised to the 3x plus 1 power equaling to 2 to the 5th power. So I notice that I only have that one base on the left side and that one base on the right side, so I already have my exponent by itself on that left side. Step 2 says rewrite the equation with the same base on both sides. Use your power cheat sheet. So right here, I already see that this is to the base of 2 and that is to the base of 2. They are already the same base. So I move on to step 3. Step 3 says set the exponents equal to each other. So once I have that base equal to that base, all I have to do then is set my exponents equal to each other. So 3x plus 1 equal to 5. And now I follow step 4, which says solve for the variable. So this becomes another linear equation. I have to isolate that variable. So I do the opposite operation, which is subtract 1 on both sides. I have 3x, 1 plus 1 is 0. Bring down my equal sign. 5 minus 1 is 4. I then isolate my variable. So if I am multiplying by 3, I do the opposite, which is divide by 3. And I get x equaling 4 thirds. Let's scroll this up a little bit. So x equals 4 thirds. Now, before I can go ahead and move on and say that's my final answer, it's always good to check what your answer is. So what we're going to do then is we're going to take that x equals 4 thirds and we're going to substitute it back into our equation where we see that x. Alright, so I'm going to bring that original problem over. 2 raised to the 3x plus 1 power, set equal to 2/5. Alright, I'm going to substitute what my x was, so bring down my base of 2. 3 times what x was, which is 4 thirds, plus 1. Remember that that's still a part of my exponent, equals 2/5. Alright, simplifying on the left side, my base is a 2. 3 times 4 thirds becomes 4 plus 1 is 5. So yes, those are equal. I am good to go. That answer is correct. We're moving on. Still following those same steps as before. In step 4, you see that my bases are not alike. I have 3 raised to the x half power plus 2 equaling to 81. This is a base of 3. This is a base of 81. I have to change 81 to have a like base of 3. So this is where that power cheat sheet comes in handy. And if I pull that up, I'm going to be looking at these numbers, right? If I know that the original base was a 3 on the left side, what answer then, looking at my 3, so anything in these columns, has that base of 3 that equals 81? Well, I see that right there. Right, 3 to the 4th equals 81. So I'm going to go back over here, and I'm just going to write that for myself on the side. 3 to the 4th equals 81. Now, that is how I'm going to rewrite this left side, or the right side, my apologies. So, left side doesn't change. 3 raised to the x over 2 plus 2 equals. I have to change 81 to have the same base. And we just did that right here. So I'm going to bring down 3 to the 4th power. Now, my bases are alike. I can go ahead and set my exponents equal to each other. So x divided by 2 plus 2 equals 4. And I solve my linear expression. So if you need to write that dotted line for yourself, I'm going to go ahead and subtract 2 on both sides. X over 2 equals, right, 4 minus 2 is 2. Keep going here. I'm currently dividing by 2, so the opposite is to multiply by 2 on both sides. So x is going to equal 4. Right now, we want to make sure that we check that answer. Going back to our original equation, 3 raised to the x over 2 power plus 2 equals 81. Well, we know that x is equal to 4 now. I'm going to substitute that where I see my x. So that's going to be 4 over 2 plus 2. 4 over 2 is 2 plus 2. Right? 3 to the 4th equals 81. And we do know that that's true because 81 equals 81. So yes, that is my final answer, and I can go on to the next example. So looking at example 3, I have 4x to the x minus 2 power set equal to 8. So sometimes we have to change both sides of our equation because we need to find those like bases. So I'm looking at 4 and 8. And if I look at my powers cheat sheet, well, I see 4 right here. Right? First instinct was like, let me check my 4s. But I never see an 8, right? I see this 4, but then it already jumps to 16. So I know the base of 4 is not going to work. So I have to look for something a little bit smaller that can accommodate both bases. And I see those 2 right here. So 2 squared is equal to 4, and 2 cubed is equal to 8, which are the 2 bases that I need. And now I'm rating both sides in the same base. So just like before, I think it's always best to write what you're going to be using. Like I said, I'm only rewriting that 4. So 4 can be rewritten as 2 squared. And rewriting this 8 to be 2 cubed. Right? Now, what I wrote in parentheses is the only thing I am changing. I rewrite that 4 to be 2 squared. The rest of the exponent stays exactly the same. I'm not going to change this x minus 2 power. Bring down my equal sign. Like 8, I have 2 cubed. There's nothing else on that side, so if you want to use parentheses, you can. Otherwise, you can leave it. Now that I see I am in the like base, right? I have a base of 2 here, base of 2. I follow the same steps as before. Now that the bases are alike, I can set my exponents equal to each other. Now remember the product property. When the exponent is on the outside, we actually multiply these. So I'm going to have 2 times x minus 2. Right? I use that parentheses to indicate we're multiplying. And then I have 3 times, well, we know that that's an invisible 1, so if you need to write that for yourself, you can. Otherwise, you just have that exponent on the screen. All right, now we simplify. I want to distribute my 2 into both terms. So 2 times x is 2x. 2 times a negative 4, the negative 2 is a negative 4. 3 times 1 is 3, and now I isolate my variable. To bring down that dotted line, I'm going to do the opposite operation. So if I'm subtracting 4, I'm going to go ahead and add 4 to both sides. Alright, I have 2x equals 3 plus 4 is 7. I have 2 times x, and the opposite is dividing by 2 on both sides. So therefore, we get a final answer of x equals 7/2, which we do have to check. Over here on the right side where we're going to check our answer. So always go back to that original answer. 4 raised to the, well, my x is 7/2 minus 2. Minus 2 equals 8. So now I want to check that left side. I'm going to go ahead and open up my calculator here. And I'm going to do exactly what it said. 4 raised to the 7/2 minus 2. Don't forget to tab over because that minus 2 is not in the denominator. Click enter and I see that I do get that answer of an 8. So I checked my answer. It's good to go. I know that this is going to be 8 equaling 8. Good. Move on to my last example. So looking at example number 4. I have 3 raised to the 2x minus 1 plus 1 equals 27. Little different than what we were working with before, because I see that my variable is not by itself on that left side. I have that plus 1. So I have to get rid of that by doing the opposite operation, which is subtract 1 to the other side. Alright, you always want to make sure that that variable is by itself. So 3 raised to the 2x minus 1 equals 28 minus 1 is 27. So before I can even set my exponents equal, I have to make sure that I have like bases. Right, this 27 is raised to that first power, but I look back at my cheat sheet. So cheat sheet over here, if I have a 3, can 27 be written as a base of 3? Yes, it can. Right here, I see that 3 cubed is equal to 27. So I like to write that for myself on the side here. That 3 cubed equals 27. That is how I'm going to be rewriting 27. Left side doesn't change, right? I have that 3 raised to the 2x minus 1 power. My 27, though, whatever I have in parentheses, my 27 raised to the first power can be rewritten as 3 cubed. Alright, now that I have like bases, right, the base of 3, base of 3, I can set my exponents equal to each other. So I'm going to have 2x minus 1 equals to 3. Becomes a linear equation. I can just go ahead and solve for my variable. Do the opposite operation, so I'm going to add 1 on each side. Again, if you need those dotted lines, you can bring those down. So 2x negative 1 plus 1 is a 0. 3 plus 1 is 4. I am multiplying 2 times x, so I do the opposite operation, which is divide by 2. X then is going to equal 2. And I'm going to go ahead and check that answer into the original problem. So 3 times 2x minus 1 equals, plus 1, equals 28. 3, my x was 2, minus 1, plus 1 equals 28. 2 times 2 is 4, minus 1 is 3, plus 1 equals 28. Well, we know that 3 cubed is 27, plus 1 is 28, which, yes, 28 does equal 28. My answer is correct. I can go ahead and move on to activity 1D.2.